China is building AI classrooms of the future, and what's going inside them will change education forever. Right now, across hundreds of thousands of schools, they're installing technology that can read your mind, adapt to how you learn, and teach every student differently at the exact same time. We're talking about cameras that track your eyes, algorithms that detect confusion on your face, and AI systems that know when you're struggling before you even raise your hand. This isn't some pilot program in a few elite schools. This is happening at a scale the world has never seen, and what they're putting inside these classrooms sounds like science fiction. But it all starts with the hardware. Walk into one of these new AI classrooms, and the first thing you'll notice is the cameras. Not just one or two, but 6 to 8 high-definition cameras mounted in every corner of the ceiling, each one capable of tracking 30 students simultaneously. These aren't security cameras. They're sophisticated facial recognition systems with infrared sensors that can detect the tiniest changes in your expression. Then there's the smartboard at the front of the room. It's not a whiteboard with a projector. It's a 15-foot interactive display running on dedicated graphics processors, responsive to touch, voice commands, and even gestures from across the room. Every single desk has a biometric scanner built into the surface. Place your hand on it, and the system knows exactly who you are, pulls up your personalized learning profile, and syncs your tablet to the lesson that's perfect for your skill level. The tablets themselves are custom-built, running proprietary educational software connected to central AI servers through dedicated 5G networks. But here's where it gets intense. Embedded in the walls are emotion recognition sensors, small devices about the size of a smoke detector that use thermal imaging and micro-expression analysis. They're measuring your engagement level 60 times per minute. The physical transformation is staggering. Traditional classrooms had a chalkboard and desks. These new spaces have more processing power than entire schools used to have. The wiring alone is incredible. Fiber optic cables running through every wall, connecting to network switches capable of handling 10 gigabits per second. The electrical infrastructure had to be completely rebuilt because these systems draw massive amounts of power. Air conditioning units were upgraded because all this technology generates heat. China isn't just adding computers to classrooms. They're gutting buildings down to the concrete and rebuilding them as data collection hubs. And every single sensor is feeding information to something far more powerful. All that hardware is useless without the artificial intelligence running behind it. And the system China built to process all this classroom data is absolutely massive. We're talking about dedicated data centers, some the size of football fields, filled with thousands of servers, running neural networks trained on over 100 million student interactions. Every camera feed, every tablet input, every biometric reading gets sent to these AI processing hubs in real time. The bandwidth requirements are insane. A single classroom generates roughly 5 terabytes of data per week. Multiply that by hundreds of thousands of classrooms, and you're looking at data flows that would crush normal internet infrastructure. But here's the tension. This AI doesn't just collect information, it has to make sense of it instantly. When a student's facial expression shows confusion, the system has less than 2 seconds to identify the problem, adjust the lesson difficulty, and deliver new content to that specific student's tablet, all while continuing to teach 29 other kids at their own personalized pace. The computational challenge is enormous. The algorithms are analyzing eye movement patterns, cross-referencing them with performance data, comparing current comprehension to past learning speeds, and generating custom explanations on the fly. To handle this, China deployed what they call edge computing nodes. These are smaller AI processors installed in every school building, handling immediate decisions locally so they don't have to wait for data to travel to distant servers and back. Think of it like having a mini brain in each school that talks to the master brain in the data center. The master brain updates its teaching strategies based on what's working across millions of students, then pushes those improvements back to every edge node simultaneously. It's a learning system that gets smarter every single day because it's learning from everyone. The processing architecture is built on specialized AI chips, designed specifically for educational applications. These aren't standard computer processors. They're optimized for pattern recognition and natural language processing, capable of understanding student questions asked in regional dialects, slang, even broken sentences. And the neural networks keep evolving. Every night, when students go home, The system analyzes the day's data, identifies which teaching methods worked best, and rewrites its own algorithms to be more effective tomorrow. But raw processing power means nothing if the AI can't actually teach. Here's where the technology becomes genuinely incredible. The AI doesn't just know when you're struggling, it changes how it teaches you in the middle of the lesson. Let's say you're learning algebra, and the AI detects through your eye movements that you've read the same problem 3 times without attempting to solve it. Within seconds, your tablet screen changes. The problem doesn't disappear. Instead, the AI breaks it down into smaller steps, adds a visual diagram, and presents a similar but simpler example. If you solve that one, it gradually increases complexity until you're back to the original problem. If you're still stuck, it switches teaching methods entirely, maybe showing you a short animation or presenting the concept through a real-world scenario it knows you're interested in based on your past performance data. Now multiply that by 30 students in one classroom, each one receiving completely different instruction at the exact same moment. One student is racing ahead on advanced calculus. Another is getting remedial help on basic fractions. 5 kids are watching interactive videos. 8 are working through practice problems. 3 are taking a quiz. And the AI is managing all of it simultaneously, making thousands of micro adjustments per hour based on how each student responds. The system tracks success rates down to individual question types. It knows that you specifically struggle with word problems involving percentages, but excel at geometric proofs. So it gives you more percentage practice, while letting you move faster through geometry. But then came the breakthrough that changed everything. The AI started predicting learning difficulties before they happened. By analyzing patterns in how you interact with material, the speed of your responses, even the pressure you apply to your tablet screen when you're frustrated, the system can identify that you're about to hit a wall with a concept 2 or 3 lessons before you actually get there. So it preemptively adjusts your learning path, introducing foundational concepts earlier, giving you extra practice on prerequisite skills, essentially preventing confusion before it occurs. The results are staggering. Schools using these adaptive AI systems reported average test score improvements of 35 to 40% within the first semester. Students who were failing math suddenly testing at grade level. Kids who were bored in traditional classrooms now working 3 grade levels ahead. Learning disabilities being identified in weeks instead of years because the AI detects patterns human teachers would miss. Students with dyslexia getting text formatted specifically for easier reading. Kids with attention difficulties receiving lessons in shorter, more engaging bursts. The system doesn't just teach one way. It has thousands of teaching strategies, and it figures out which one works for you. And this personalized instruction doesn't stop when the bell rings. The classroom AI follows you home. Every student gets a mobile app connected to the same system that taught them during school hours. It's a personal tutor, available 24/7, who knows exactly where you struggled today and what homework you need to complete. You're stuck on a chemistry problem at 9 at night. You open the app and just speak, "I don't understand how to balance this equation." The AI responds in seconds, walking you through it step by step, using your exact learning style. But here's what makes this incredible. The system provides instant feedback on your work before you even submit it. Write an essay, upload it, and within 30 seconds you get detailed notes on structure, grammar, and argument strength. The AI generates practice problems perfectly calibrated to your skill level. Not too easy, not too hard. And it knows when you're getting tired. After 45 minutes of homework, if your response times slow down, the AI suggests you take a break. On any given night, tens of millions of students access these AI tutors simultaneously. Peak usage hits between 7 and 9 in the evening. The servers were built to handle that surge without lag. Response times stay under 3 seconds, even when 20 million kids are asking questions at once. But the technology wasn't stopping at homework help. China started installing virtual reality headsets in classrooms, and suddenly students could step inside their lessons. You're studying the Great Wall, and instead of looking at pictures, you're standing on it during the Ming Dynasty, watching construction crews haul stones up mountainsides. The headsets connect wirelessly to the classroom AI, generating these environments in real time. 30 students exploring the same virtual world simultaneously, each seeing it from their unique perspective, all powered by servers processing billions of calculations per second. But then they added holographic projection systems. These don't require headsets at all. A beating heart appears, floating above your desk, life-sized, rotating while the AI explains blood flow. You can walk around it, view it from any angle, reach out and touch specific parts to trigger detailed explanations. For science classes, students perform dangerous chemical experiments virtually that would be impossible in real labs. Mix volatile compounds and watch realistic reactions without any safety risk. The augmented reality integration is just as impressive. Hold your tablet over a regular textbook and watch diagrams come alive. A flat illustration of a volcano transforms into an animated cross-section showing magma movement. Historical maps overlay modern satellite imagery, showing how cities evolved over centuries. The investment is massive. Schools spending hundreds of thousands of dollars per classroom on VR headsets, holographic projectors, and the computing power to run them. 5G networks upgraded to handle streaming high-resolution three-dimensional content to multiple devices at once.